The search begins. For centuries, humans have gazed at the stars, driven by a deep curiosity about the universe. As our understanding of the cosmos grew, so did our desire to explore the unknown. In our own solar system, astronomers had identified 8 planets, but the quest for knowledge did not end there. The search for a mysterious 9th planet, often referred to as Planet X, became a tantalizing pursuit. The concept of Planet X emerged in the late 19th century. Astronomers observed irregularities in the orbits of the outer planets, particularly Uranus and Neptune. These slight gravitational wobbles hinted at the possibility of an unseen object lurking beyond Neptune. This mysterious object, astronomers speculated, could be a massive planet, hidden from view, but exerting its gravitational influence on its celestial neighbors. The idea of an undiscovered planet captured the imagination of scientists and the public alike. The stage was set for a scientific adventure, a quest to uncover the secrets of our solar system and unveil the existence of Planet X. This pursuit would span decades, leading to unexpected discoveries and reshaping our understanding of the solar system's outer reaches. Among the most prominent figures in the search for Planet X was Percival Lowell, an American astronomer with a passion for the cosmos. Intrigued by the orbital anomalies of Uranus and Neptune, Lowell dedicated himself to finding the elusive planet he believed was responsible. In 1906, he founded the Lowell Observatory in Flagstaff, Arizona, specifically for this purpose. Lowell meticulously calculated the predicted location of Planet X based on the gravitational perturbations observed in the outer planet's orbits. Armed with his calculations and fueled by an unwavering belief in its existence, Lowell spent years tirelessly scanning the skies. He used a powerful telescope and photographic plates to capture images of the night sky, hoping to pinpoint the faint glow of the unseen planet. Despite his best efforts, Lowell's search for Planet X proved fruitless during his lifetime. He died in 1916, his dream of finding the elusive world unfulfilled. However, Lowell's legacy lived on, and his observatory continued the search for Planet X, driven by the belief that their founder was on the right track. 14 years after Lowell's death, a young astronomer named Clyde Tombaugh made a historic discovery at the Lowell Observatory. On February 18, 1930, while carefully examining photographic plates, Tombaugh spotted a faint point of light that shifted position over time. This telltale sign indicated an object moving against the background stars, a potential planet. The discovery sent shockwaves through the scientific community and captured the world's imagination. The long-sought-after Planet X, it seemed, had finally been found. The newly discovered object was named Pluto, after the Roman god of the underworld, a fitting name for a world residing in the distant dark reaches of the solar system. Pluto's discovery was hailed as a triumph for astronomy and a testament to Percival Lowell's vision, even though he was not alive to witness it. The discovery also expanded the boundaries of our solar system, adding a 9th planet to the known roster. However, as astronomers would soon learn, Pluto was not the massive Planet X that Lowell had envisioned. In the decades following Pluto's discovery, astronomers continued to study this distant world. However, as they gathered more data, it became increasingly clear that Pluto was much smaller than initially thought. Its gravitational influence on Uranus and Neptune, the very anomalies that had sparked the search for Planet X, was too weak to account for the observed orbital irregularities. Then, in 1992, astronomers made a groundbreaking discovery that would revolutionize our understanding of the outer solar system. They detected a faint object orbiting the Sun beyond Neptune, the first confirmed member of what would become known as the Kuiper Belt. This vast region of space, named after astronomer Gerard Kuiper, is a reservoir of icy bodies left over from the early solar system. The discovery of the Kuiper Belt shed new light on Pluto's true nature. Rather than being a lone planet, Pluto was now recognized as one of many icy objects inhabiting this distant region. This realization sparked a debate within the scientific community about Pluto's planetary status, a debate that would eventually lead to a significant reclassification. Section 5: Pluto demoted, a dwarf among giants. As astronomers continued to study the Kuiper Belt, they found more and more objects similar in size and composition to Pluto. One such object, Eris, discovered in 2005, was even more massive than Pluto. This discovery forced astronomers to reevaluate their definition of a planet, as it became clear that Pluto was not unique in its characteristics. In 2006, the International Astronomical Union, or IAU, formally defined the term planet for our solar system. According to the new definition, a planet must meet 3 criteria. It must orbit the Sun, be massive enough for its own gravity to pull it into a spherical shape, and have cleared its orbital neighborhood of other objects. Pluto, while meeting the first 2 criteria, fell short on the third. Its orbit overlapped with those of other Kuiper Belt objects, meaning it had not cleared its neighborhood. As a result, the IAU reclassified Pluto as a dwarf planet, a new category created to accommodate objects like Pluto and Eris. Section 6, Planet 9. A new hope emerges. The demotion of Pluto to dwarf planet status seemed to close the chapter on the search for Planet X. However, just when the idea of a 9th planet seemed to fade into scientific history, a new discovery rekindled the hope of finding a hidden world in our solar system. In 2016, astronomers Konstantin Batygin and Michael Brown at the California Institute of Technology announced compelling evidence for a hypothetical 9th planet dubbed Planet 9. Their study, based on the unusual clustering of orbits observed in a group of distant Kuiper Belt objects, suggested the gravitational influence of a massive, unseen planet lurking far beyond Pluto. Batygin and Brown's findings reignited the quest for Planet X, albeit with a new name and a much more distant target. Their work presented a tantalizing possibility that a hidden world, perhaps 10 times the mass of Earth, could be shaping the orbits of objects in the outermost reaches of our solar system. Section 7. The Evidence Gravitational Anomalies. The evidence for Planet 9 hinges on the peculiar orbital alignment of a handful of distant Kuiper Belt objects. These KBOs all have elliptical orbits that point in roughly the same direction in space, an extremely unlikely occurrence by chance alone. Batygin and Brown's simulations showed that the gravitational pull of a distant, massive planet could explain this unusual clustering. According to their calculations, Planet 9 would be a super-Earth, with a mass about 10 times that of Earth, and an orbit hundreds of times farther from the Sun than Earth's orbit. This hypothetical planet would take between 10,000 and 20,000 years to complete one orbit around the Sun, making its detection incredibly challenging. While the orbital alignment of these KBOs provides the most compelling evidence for Planet 9, it's not the only clue. Astronomers have also observed other gravitational anomalies in the outer solar system, such as a slight tilt in the Sun's spin axis relative to the plane of the planets, that could be explained by the presence of a massive, distant object. Section 8. The search continues. A needle in a haystack. The evidence for Planet 9 is intriguing, but it's important to note that it remains hypothetical. Astronomers have not yet directly observed this elusive world, and its existence is still debated within the scientific community. However, the search for Planet 9 is in full swing, with astronomers around the world eager to catch a glimpse of this distant world. Finding Planet 9 is no easy feat. Its predicted distance and faintness make it an incredibly challenging target, even for the most powerful telescopes. Astronomers are using a variety of techniques to try to pinpoint Planet 9's location, including searching for its faint glow in the infrared spectrum and looking for subtle gravitational effects on other objects in the outer solar system. The search for Planet 9 is a testament to the enduring power of scientific curiosity. The possibility of a hidden world lurking in the distant reaches of our solar system is a tantalizing prospect, and astronomers are determined to unravel this cosmic mystery. Whether or not Planet 9 is ultimately found, the search itself is expanding our understanding of the solar system and the universe beyond. Section 9. Conclusion. The ever-evolving solar system. The journey from the early concept of Planet X to the modern search for Planet 9 is a testament to the ever-evolving nature of scientific discovery. What began as a quest to explain orbital irregularities in the outer solar system led to the discovery of Pluto, the Kuiper Belt, and a deeper understanding of the dynamics of our cosmic neighborhood. While Pluto's reclassification as a dwarf planet may have disappointed some, it ultimately reflected a more nuanced and accurate view of the solar system's diverse population of objects. The discovery of the Kuiper Belt and its countless icy inhabitants revolutionized our understanding of the solar system's formation and evolution. The ongoing search for Planet 9, whether or not it proves successful, exemplifies the spirit of exploration and discovery that drives scientific inquiry. Each new observation, each new calculation brings us closer to unraveling the mysteries of the cosmos and expanding our understanding of our place in the universe. The solar system, far from being a static and unchanging place, is a dynamic and evolving system, full of surprises waiting to be discovered.